2, 1. This video is going to be about quadratics and tying in the parabolas, which basically are quadratics, and finding the vertex of a parabola. Now, you may recall that parabolas are symmetric, so they have some source of symmetry. I did actually a video on finding the symmetry line for parabolas. I'll put the link up above. You should know that before you watch this. Now, parabolas basically either open upwards or they open downwards. So you have something like this. So you either have parabola like that, or it's going to look like that. Now, the vertex itself is always known as simply the minimum or the maximum point on the parabola. So if you have your parabola opening up upwards, or if you have your parabola opening up downwards, then your vertex is at a different place. And here, your vertex would be right there, and then it would be right there for the parabola going downwards. Now, a vertex is a point, so it has an x and a y for both of these. Now, of course, they're going to be some numbers that we have if we have a specific quadratic. And for your line of symmetry, so let's bring that back a little bit. Here is the image of one particular example. Now, this image I took from graphing it on Desmos, which we're going to be using in this video. Here is your quadratic. So this is actually a relationship between y and x that you have. Negative 2x squared minus 5x plus 2. It is graphed out. This one is looking downwards, and it should make sense to you because a is less than 0. And your vertex would be right there. Now, the line of symmetry that we have, which we're going to need, is basically the line that divides this thing, all right, into a nice symmetrical shape both on the left and on the right hand side. So I'm going to try to run this right through the vertex because that's what the line of symmetry goes through. It goes right through the actual vertex. Now, we were able to find that line of symmetry, so it is basically x equals to something. And I'll try to kind of go back to this example as well at the end. And we're going to be able to find that vertex. So our goal is going to be kind of 2 steps. Our goal is going to be able to first find the line of symmetry, which means we're going to try to find where that line of symmetry, where it goes through the x value. Once we have the x value, we can substitute the x value into the relationship between y and x, and then solve for our y to get exactly the point, which is the vertex. Now, you may know that quadratics have different forms. So there's special ones which you can factor, some other ones you may not be able to factor, but there should be some way, some natural way of you going about trying to find a vertex for all of these different things. Now, what I like to do is, when I am working with these, I always try to find, because there is such symmetry here, I'll try to find 2 points. So I'll try to find 2 points which are basically on the same y value on the actual graph. Now, if it's in factored form, then it's easy to do because then I will just look for the zeros, which means basically where y is equal to 0. And then I will take the 2 points right here. And again, to find the line of symmetry, I will add them up, divided by 2. So I'm finding the average, which is going to give me this value of x. And now I can do that for any point, right? So I could have, done it right here where I could have taken these 2 points. I could have done it right here. So it doesn't matter which ones you take, but they will all yield you the same x value. And once you have the x value for that, you will substitute the x value and you will get your vertex, which is going to be that. It's going to be some x, which is from your line of symmetry, and then it's going to give you your y. those are going to be the steps that we'll try to follow. Let's take a look at a few examples. Here are 4 examples that I have for you. Now, the first example, you notice, is a difference of squares. The second example is an example of a perfect square. The third example is already a quadratic in factored form. And then the last example is a quadratic which is not in factored form, just in general. Now, all of these can have different approaches, but really, if you know one of the approaches, then that's good enough. And that's what I showed in that line of symmetry video, which I pointed out in the beginning, which you can watch. Now, for the difference of squares, so if I wanted to be able to find, now of course I can factor this out and I can find the zeros here. And the zeros, I can then take those zeros and then find my x value for the line of symmetry. Here, for the perfect square, I again already know what my zeros are from here because this is already in factored form and it's a perfect square. So it's going to have exactly the same thing, and you'll see that that basically yields you your vertex. And then here again, because it's in factored form, I can find the zeros and I'm good to go. Now, the problem always is when it's not in factored form, but when it's not in factored form, it actually turns out that it's not that difficult to find the vertex either. So let's look through these examples. I'm going to break them down. For the first one, so for this one right here, I can factor it out because it's a difference of squares, but I won't. What I'm going to do is, what I like to do is, whenever I have a quadratic, I like to set my y equal to c. And you may recall that for quadratics, what you have is you have a x squared plus bx plus c. Now, if it's a relationship between y and x, then it's going to look something like this. And what I like to do is I like to set my y equal to c. And then I like to find the zero, which is going to find those 2 points on that parabola. So let's do that. All right, so we'll do that right now. And in this case, what I'm going to do is I'm going to set the y equal to negative 36 equals to 9x squared minus 36. Now, this negative 36, when you bring it over to the other side, you will notice that it's going to cancel that because it's negative 36 plus 36. And this beautifully just gives us 9x squared. And now notice what this means is that I have my x value, right? What will make this 0 is x is equal to 0. And I have 2 of them because it is, okay, second degree. So I have x is equal to 0, which is going to make this 0. And because they're identical, then it turns out that this is actually the vertex, right? So what makes this 0, so I have now found the point, because remember, my y I set to negative 36. So my x is 0, so this is 0, negative 36. And for the difference of squares, that will always be your vertex. This point is exactly on the vertex whenever it's a difference of squares when you take the c. And if you graph this out, and let's do that, I'm going to use it with decimals. So it's 9 and negative 36. Y is equal to, this was 9x squared minus 36. And notice, let me blow this up for you. And this is exactly the vertex, which indeed is at the point 0, negative 36. That's what happens with difference of squares. So if you notice that, then you right away have found the vertex, right? And that vertex, obviously, so the line of symmetry goes through that. Now, what about if it is a perfect square? So if I go back here and I take this 2x plus 3 squared, how would I work that out? Now, I don't have to expand this out necessarily. And what I have is for the second one, 2x plus 3 squared is equal to y. And again, because this is already a perfect square in its factored form, then in this case, I can just find, and I will set y is equal to 0. and that is going to give me 2x plus 3 squared. And now if I solve this, then what I need to find where will this equation equal to 0. So 2x plus 3, all right, so I have that. I can shift this over on the other side. I'll have 2x minus 3, divide by 2 on both sides, and I'll get that. And of course, I had 2 of them, right? I had 2 of these. And because I had 2 of them, just like for the difference of squares, so for perfect squares, so what I have this is times, I shouldn't say times 2, but I basically have 2 of these roots or 2 of these zeros. And what this means is, if you find that these are identical, then you found your vertex. And this means that, so this is negative 1.5, I guess, 0. And again, because if you add them up, because they give you the same point, if the same point added together divided by 2 gives you this point back. And for difference of squares and for perfect squares, this is how you can find the vertex directly. So that is great. And so if I go back here, and I'm going to plot this out now, so 2x plus 3, and you will notice that here you go, here's your parabola that you have. It does look upwards, and you have negative 1.5, 0, right? We have 2 of those roots, so they're basically just touching there, and that is your vertex. So difference of squares and perfect squares, to find the vertex is rather simple. You know, there isn't a lot to do. Now, what happens if they're not a difference of squares or perfect squares? And for here, let me take this example, for instance, which is in factored form. I'm going to take this, let me copy it. So it is a quadratic. Now, you should already notice that you have a negative 4 in front there, which has been factored out. And that negative 4, because it's negative, so we know that this parabola is going to look downwards. In the previous 2 cases, the parabola was looking upwards because our a, okay, was positive. Now here, our a would have been negative if we distributed everything out because of that negative that we have there. And so what do I do here, right? How do I find my vertex here? It's not a perfect square. It's certainly not a difference of squares. And so this one is going to be an additional step. So if it's factored, then what you can do right away is say, all right, well, it's factored. So I'm going to set y is equal to 0. And that's going to give me negative 4, 5x plus 2, x minus 3. And now what I'm trying to find is, when is this equation? For what values of x is this equation 0? Well, the values of x are going to be these 2. 1, 2, they're going to come from these 2 factors. So your first 0 is going to come from here, 5x plus 2. If you make that equal to 0, and that's going to get shifted over, 5x, x is equal to negative 2 over 5, which is, I guess, negative 0.4. That's your first point. So your first point is negative 0.4, 0. That means we have found a point on our parabola here, and it is a 0. That's one of them. Now the second one, which is going to come from right here, this one is easier. X minus 3, if we set equal to 0, bring this over, x is equal to 3. So my second point is going to happen at 3, 0. And these are your 2 zeros, so these are your points, which are basically your x axes, so the x-intercept of this parabola. So this parabola is looking downwards and it intercepts within here. Now, in order to find, so now if I wanted to find the line of symmetry, right, I have to add these 2 points and then divide it by 2, so find the average, because I want to find the middle ground, so that would be my line of symmetry. Well, what is the line of symmetry here? Well, adding 3 plus the negative 0.4, so that's going to be 2.6. Now 2.6 divided by 2 is 1.3, which means your line of symmetry actually is running through x is equal to 1.3. That is where your line of symmetry lies. Once you find this, you can now take that and substitute it back into this equation for x, and then find what the value of y is, and that will be your vertex. Let me visually show you what happens here. All right, so here it is. I just put it in. So -4, 5x plus 2, x minus 3, so that's the factored form. And so here are, so notice that it's 3, 0, so that was one of those intercepts, and then -0.4. And then again, if we added it, so our vertex right there, notice it's at 1.3, which is correct. Notice the y value is 57.8. But we graph this, right? What we want to be able to do is not take it from a graph. We want to be able to take it right from the equation. And so notice what I'm going to do is I'm going to say, okay, so what is y when x, this is 5 times 1.3 plus 2. So I'm substituting it back into here. This is 1.3 minus 3. Now I have to work this whole thing out. So what is that? And let me take out calculator here. All right, so let me substitute it all back in so it's a little bit quicker. So -4 times. And then it is, so 5 times 1.3 plus 2. So that's in brackets, multiplied by, and then I have 1.3 minus 3. And then that is in brackets. And notice, indeed, it is 57.8. That is your vertex at that point. So your line of symmetry happened at x is equal to 1.3, and obviously that line of symmetry has to go through your vertex. And that's how we are finding the vertex within here. And that is, if it's already in factored form, that's what you can do. Now, what happens if it's not in factored form, right, for these quadratics? You know, so you have all of these different variations that can happen. And for this, you know, so if I have that, so let me copy. And I'm not going to bother to try to check if this is going to be factorable or not, right? If I can do it, because not everything can be factored. So I'm not going to bother here. And as I said, just as I did with the difference of squares, and as I did in the video for the symmetry line, all I really do is, if it's not factored, I will just take this, okay, and set it to y. So then I can find the zeros for that. And so for that, so let y, so y is going to be, so y is going to be 8. And now I'm going to try to find, because it's a quadratic, so I'm going to find the two x values when x is equal to 8. So those symmetric values. And this is 2x squared plus 3x plus 8. Of course, the 8, when you move it over, that will cancel it, which means this is going to be 0. 2x squared plus 3x, which is going to give me, now I'm going to factor out the x from here, and that's going to give me 2x plus 3. And now I can find the two zeros. Well, one of the zeros is always going to be at x equals to 0, because if you set x equal to 0, it will make this equation true. Then the other one is going to come from here. 2x plus 3 is equal to 0. So shift this over, it's going to be -3. 2x divided by 2 on both sides. And that is -1.5. So here are my 2 points where y is equal to 8. And 2, 3, 8, let me go back here like this. And notice this one doesn't go through the x-axis. So we wouldn't be able to factor this out at all. We found 0, 8, and we found this was -1.58. And let's label them. We have that. Those were the 2 points we found. Now, why did we find them? Because we want the line of symmetry. So notice now what I'm going to do is I'm going to add the 2 points and then divide by 2. -1.5 plus the 0, so -1.5 divided by 2 is -0.75. And notice your vertex indeed is -0.75. And now to find that 6.875, that y value, I have to substitute the line of symmetry line, which happens at x equals to -0.75. And when I substitute it back in, then I will find my value of y. There are other ways to find a vertex, and you will learn about that later on, because there's special kind of formats for the quadratic in vertex form. Like, they're called the vertex form of a quadratic. But if they're not in that form, and you haven't learned it yet, this is a great tool to have. And this is as far as I'll take it with these examples. I hope that they were useful, and we'll see you in a future video. Okay, take care everyone. Bye.